Okay, so going back here in this example, Chihuahua has a length of 2.65 centimeters. And in this particular case, well, it should be in centimeters, by the way. It should not be in millimeter. Okay, so you're using a ruler. The uncertainty in this measurement is based on the instrument used, the ruler. The uncertainty of the ruler is plus or minus 0.05 centimeter. So this actually means that the actual length of Rex, the Chihuahua, would be in between 2.6 centimeters or 2.70 centimeters. Well, 2.6 is the minus 0.05, and this would be the upper limit of plus 0.05. So again, 2.60 there represent the 2.65 minus 0.05 centimeter. And the 2.7 is the upper limit, which is plus 0.05. So that means that more likely the actual length of Chihuahua is between 2.60 and 2.70 centimeters. So how do we define accuracy and precision? So when we say accuracy, you're actually pertaining to how close the measurements are to the accepted value. Okay, accepted value means, like, for example, the values that we can see in tables. So for example, density of water at certain or certain conditions, pressure and temperature, we say that it's 1.0 gram per cubic centimeter. So that's the accepted value. And if you try to do an experiment verifying the density of water, well, you're going to compare to your result to that accepted value. That would be your accuracy. So if it's higher or lower than that. So accuracy always means that you're comparing your measurement to the accepted value. So again, usually you see this one in tables. Okay. So let's say, for example, here in Vancouver, we have a particular accepted value of acceleration due to gravity. So acceleration due to gravity essentially changes with location because it's also dependent on the altitude or the height of the location. So although we use around 9.8 as a standard value or the accepted value, okay? While precision, on the other hand, when you say precision, it would be how close measurements are to each other, okay? So when we try to do a particular measurement, and then every time we try to get that value, we get more or less the same value, we say that that particular measurement is precise. So it's just talking about how close the measurements are to each other. Okay, let's say, for example, using the example number 1 here, the ruler. So when you use the ruler, you get same value of 2.65. So you would say that your measurement is precise. It gives you the same value over and over again. Okay, and usually the number of significant figures is a measure of precision. Okay, so the number of significant figures gives you some sort of the measure of the precision of your measurement. Because you can also, well, if you are aware of a Vernier caliper, another measuring instrument, it can read up to, I think, 0.01 of a millimeter. So that is more precise. Again, we're not yet sure if it is accurate, because if we say accuracy means that it should be compared to the accepted value. Okay, so see the difference between the two. Precision is just talking about the measurement. You try to compare it with one another. If it gives you the same value, you could say that that is precise. Same thing with a thermometer, for example. So for example, you try to get the temperature of a person, or at least for yourself, and every time you use the thermometer, it gives you, let's say at first it's 36.5, and then second measurement you get 36.4, and then another measurement is 36.5, and then another measurement you get 36.4. So I would say that that is precise thermometer, or your measurement using the thermometer is precise. However, I'm not yet sure if that's accurate, because let's say, for example, if I use a particular instrument or thermometer which has a high degree of accuracy, or at least I set that one that this is my standard, and I use that one, and your temperature is 38 degrees Celsius, well, that particular measurement of yours using the other thermometer is highly inaccurate, because it's very far from the standard value of 38 degrees Celsius. So hopefully you have a good sense of the difference between accuracy and precision. So do you have any questions so far? If there's none, so these are just some examples. So these are some of the digital balances in our laboratory, here in St. Pat. So the precision is 0.01 gram. So that means that it can read 0.01 of a gram. And then for graduated cylinders, it's around 0.2 ml. Okay. If the uncertainty in the scale is not given, assume that the uncertainty is 1/10. So therefore, for example, if we are not given it's a measure of uncertainty, we just try to divide the smallest scale by 10. So let's say, for example, the smallest scale is 0.1 centimeter, and the uncertainty of that instrument is not given. So you just divide 0.1 cm by 10.
Sorry to interrupt you. If you know your grade and managing faculty, do you with basketball team and managers captain now? Do you grade basketball team and managers so we have no please? Thank you.
Okay, so yeah, so 0.1 centimeter, you divide it by 10, 1/10 is 1/10. So that's 0.01 centimeter. So that would be the uncertainty of your measurement or instrument. So this is just a diagram showing what is precision and accuracy. So in this particular case, if you can see, remember that when we are trying to shot something, we want the bullseye. So this is our aim, okay, to get the center of this circle, because that's the maximum points. But if you can see, well, you're throwing it here. So this particular diagram shows precision. So you would say that this is precise, but not accurate. So this particular whole thing here is precise, because even though you want to hit the center of this board here, well, you get almost, well, at this upper left portion of that. So this shows that it is precise but not accurate. So the second one, if you can see here, well, all of your darts are inside that bullseye mark. Okay, so in this particular case, it's actually both accurate and precise. So that means that, yeah, this is your ideal situation here. You need to hit the bullseye, and every time you also try to have or reuse that one, you get the same value, the bullseye. Okay, and the third one here, again, we want to hit the center mark. So this shows that neither, so it's not accurate, and not precise. Okay, so if they're very far off from each other, plus it's also kind of off from your from the center mark.